Karmion is an AI for computational fluid dynamics, the science of simulating how fluids like air and water behave. CFD underpins the design of aircraft, cars, turbines, and robotics, but it requires specialist engineers, expensive software, and days of setup. It is one of the most costly steps in any engineering workflow. The name is inspired by Theodor von Karman, who pioneered modern aerodynamics and spent his career studying vortices, the same physics you can now simulate by just talking to Karmion. AI can already generate a beautiful image or 3D model of an airplane wing in seconds. But ask it, will this actually fly? And it has no idea. It can look right without being right. Because generating something that looks plausible is not the same as understanding the physics behind it. That's the gap Karmion solves. We connected an AI agent directly to OpenFOAM, so instead of guessing, it runs the actual physics. I typed, simulate a lid-driven cavity flow, a classic CFD benchmark. Think of it like a snow globe, fluid trapped in a box, with the top moving sideways, pulling everything inside into a slow spin. This will take a few minutes. What would take a trained CFD engineer the better part of a day? Setting up the mesh, configuring boundary conditions, writing solver files, debugging crashes. Karmion does in around 2 minutes. While it runs, here is what is actually happening. The agent breaks the request into a structured workflow. It plans the simulation, generates all the OpenFOAM case files from scratch, launches the solver, and monitors the output in real time. If the numerics start to diverge, which happens often in CFD, even to experts, the agent reads the error logs, diagnoses the cause, applies a fix, and reruns automatically. Now let's wait for the result. Now look at the result. What you see is the actual computed answer. Not a render, not a guess. Open a new tab, Google lid-driven cavity flow. You will see the exact same flow pattern. That is how you know it is real. Now I give the instruction, increase the lid velocity to double the Reynolds number I specified initially. This is where it gets interesting. A parameter change in CFD is not as simple as turning a dial. You need to update boundary condition files. Check that the new Reynolds number stays within the solver's stability limits, and rerun, ideally from a warm start rather than from scratch. Karmion handles all of that automatically. Let us try doing that now. And you will see the updated solution once that is done. The flow pattern has changed. The vortex is stronger, the pressure gradient is steeper. Again, exactly what the physics says should happen. Building something like this is genuinely hard. CFD sits at the intersection of fluid mechanics, numerical mathematics, and high-performance computing, fields where people spend entire PhDs just to understand one corner of the problem. Getting an AI agent to navigate that reliably, catch the failures, and produce correct physics is not a prompt engineering exercise. It requires understanding what the equations are actually doing, why solvers diverge, and how to recover from it. The kind of knowledge that, historically, lived only in the heads of people with very long CVs and very strong opinions about mesh resolution. Karmion makes that accessible to anyone who can type a sentence.